All right, you're all welcome once again to today's class. Happy meeting you once again. It's been a while after 1 week. So today we are going to continue with our class on matrices, and today we are going to continue with the determinants of square matrices. Okay, in the last class we looked at multiplication of matrices, and we looked at also transpose of a matrix. Okay, so we are looking at determinant of square matrices today. And take note of the word square matrices. It means that this determinant is only applicable to square matrices. It cannot be used for non-square matrices. It's not applicable to them. And what's the determinant of a square matrix? Determinant is a representation of an operation, a matrix, that leads to a single value. Okay, so under determinants, you are going to be having a single value, either 4, minus 3 over 2, 0, 1, and all the rest of them. So that's what we mean by single value. Unlike a matrix form, in normal matrix form, you will be having an answer in matrix notation as 3, minus 1, 2, and 4. So this is a matrix. Okay, many operations in matrix lead to an answer or a value in matrix. But when we talk about determinants, we are talking about just a single value. All right. So it was derived while solving system of linear equations using elimination method. When we talk about system of linear equations, we are talking about simultaneous equation. Okay, that by system of linear equations, and using the elimination method, whereby they discover that if you want to find the value of any particular variable, then of course you have to do some mathematical manipulation and all that. So it was discovered that such algebraic manipulation has a short notation which can be expressed in determinant form, in the form of a matrix, which we call determinant. So it determines the possibility of the equation having a valid solution. Okay, so when you carry out that elimination method, that solution and all that, you discover that the value of your determinant will determine whether it is possible, whether that equation kind of will have a valid solution. For instance, if in your denominator you are having 0 and your denominator, definitely it implies that because you are having 0 as a denominator in a fraction, then it implies that the value you're going to have is going to be infinity. Okay, because a real number divided by 0 is going to give you infinity and all that. So that what I mean by it. If you have, for instance, a negative root and all that, of course, you know they're going to give you a complex value which you may not have a real solution and all that. So that's why this value determines the possibility of the equation having a valid solution. Hence, its name is called determinant. Alright, so that's just the history about determinant. We want to look at a 2 by 2 determinant of a square matrix. Alright, so example, say if A is a 2 by 2 matrix, such as A is equals to A11, and these are the elements that are upon that. The symbol we use for determinant is either we say triangle A, as you can see there, that symbol of a triangle actually implies matrix. You can see the symbol here. It's either we use the symbol or we use the symbol for determinant A, or we simply write det A, determinant A short form this way. So these are the symbols we use for determinant. And unlike in a matrix, for instance, when I have matrix of minus 3, 2, 0, 4 all over 7. This is a matrix, okay? Now, this is because of this bracket here, or parenthesis, which can also be expressed in, what do we call it now? Can also be expressed in the form of a square bracket. Can also express your matrix in a square bracket as this, minus 3, 2, 0, 4 all over 7, okay? But when you see a vertical line this way, enclosing a matrix, then they're talking about the determinant. As you can see here, so if I have written the same number, but I have written it as, with a vertical line, minus 3, 2, 0, 4 all over 7. then I am talking about determinant. So this is telling you about the determinant of this matrix. Unlike this is just talking about a matrix of element that owns all these members and all that. Okay, so that's what you have here. So if a matrix is A, determinant, if a matrix is written this way, its determinant is written this way. Now, how do we carry out operation of the determinant operation? How do we do that? The basic process of carrying out determinant operation is using the 2 by 2 determinant, which form the basic unit of calculating determinant. Just like in biology, you learned about that the cell is the basic unit of life. Okay, if I can remember all the biological stuff you learned then. So also when you are talking about determinant, the 2 by 2 determinant squared matrix serve as the basic unit. So it means that when you are solving a 3 by 3, a 4 by 4, as you maybe when you get to university or higher colleges and all that, you still have to reduce to a 2 by 2. So it means that the 2 by 2 is the basic unit. And how is it done? It just simply, you can see the arrow here, which explains what you're supposed to do. What's the name of this diagonal again? Who can remind the name of this diagonal? This one coming down. Primary diagonal. Good. So, it's called what? Either primary diagonal or what? Principal diagonal and all that. So this is the primary diagonal. So it is the primary diagonal, the product of the primary diagonal minus the product of what? The secondary diagonal. So what it means is that here in this matrix now, the primary diagonal is A11 and A22. So we're going to do A11 multiplied by A22, then minus, as you can see the minus here, minus then, of course, we now talk about the secondary diagonal, okay, or the off diagonal, okay, which is A21 times A12. So that's what we have here. So the determinant of A has been explained here. So that's what we have there. So that's how we get the determinant of a 2 by 2. So for higher orders, we'll reduce to 2 by 2 and then we'll carry out our calculation on higher orders. Okay, so let's take some examples. Example, it says, find the determinant of the following. Find the determinant of the following. Okay? Okay, so we're going to do this. So you can write, find the determinant of the following. Update your notes while I'm waiting for you. Find the determinant of the following. Let me divide the board into manageable pieces. Okay, so I believe we should be ready to work. Alright, so for question A, solution. So I'm starting here. This question is easier for you to still be writing. Alright, solution A. So start for A. So if A is given as matrix of 7, 3, 4, and 2, and we are looking for the determinant, so can I say that implies that delta A, which is determinant, is equals to the 7, 3, 4, and 2. So you can see I've used vertical line now. Then, of course, just using the product of this one minus your primary diagonal minus your secondary diagonal. So that's what I'm going to have. So what we have now, so 7 7 times 2 will give us 14. Is that not so? So we're going to have 7 times 2 as 14. So we have 14 minus 3 times 4 will give us 12. So 14 minus 12 will give us what? 2. So that's what we have. So we can now say, therefore, that determinant A, I'm using the second symbol again, is equals to 2. Any question? Any question? I think it should be simple enough, right? Okay, so we proceed in the absence of no question. So I'm going to do B, and of course, I'm expecting C from the class. So question B is equals to, is a matrix of minus 6, minus 2, 0, minus 5, and all that. So that implies that the determinant of B, I'm using another symbol now, it will give us minus 6, 0, minus 2, minus 5. Alright, so of course it's going to become minus 6 times minus 5, as I have explained. So of course the product of that two, the primary diagonal, is going to give us what? Minus 6 times minus 5 will give us what? Positive 30. Okay, then minus, then your secondary diagonal. And of course, minus 2 times 0 will get to give us 0. So you have that. So can you say that our B, so therefore, determinant of B is equals to 0. I mean equals to 30, sorry, equals to 30. So you see that determinant is a single value, unlike matrices. There are arrangements of numbers in rows and columns, but determinant is just a single value that represents the entire members of the matrix. Any question? Alright, so in the absence of no question, then of course I'm expecting you guys to do this one, and of course, and let your answer pour in now. You have just, it should not take you more than 2 minutes to do. Okay, so 2 minutes, it should be done. It's a very simple something. Okay, Andrew and Amanda, kudos to you. I love what you are doing. Zumos or NS, that's good. Ifeanyi Anyoko, you send to everyone. Why? And any Fortune, kudos to you. Kamsi, I love you for that. Yeah, Kasim, thank you. Grace, yeah, dear. Come on, come on, come on, come on. Pour it in, send it in, send it in. We are 23 people here. Favor Okafor, that's correct. God's chosen, that's nice. Apologies there, okay. You are sending to everyone, okay. I will not respond. And okay, fine, that's correct. Okay, please verify that you are sending privately to me before you send your answer, so that you don't send it to the group chat. Apologies, rest, that's correct. Kudos to you. Daniela, interesting, that's good. Precious, you are doing the wrong thing. Send it to everyone. Azike Daniel, that's correct. Bright, that's correct. 45 seconds to go. Ikide, that's correct. I will move on to the next thing. Okay, I should have 24 by now. All right, so let's continue then. So we can now move to, so it is implied that every one of us have understood this. Of course, you should, because it's very simple. Please send me a message now. Nobody is bearing Techno P703. That's not somebody's name. So this person is not in class now. Identify yourself, please. Rename yourself with the appropriate name. All right, so I proceed. You're not part of my student. All right, I proceed to the next item we have now. Okay, and okay, so talk about the place signs of matrices. The place sign of matrices. What do you mean by the place sign of matrices? Matrices have their place sign. They have what is termed the place sign of matrix. Every matrix, okay. But of course, this place sign is actually useful for square matrices. It's actually useful for square matrices. So, and the place sign of matrices is always viewed as a neutral square. You have learned about atom in your junior class, okay? That numbers of is it proton now? It's equal to numbers of what? Electron, right? Good. Okay. So, and it's always neutral. All right. So that is empty. So the place sign of matrices should be viewed as a neutral square. Okay. We start with positive and alternates with negative as we move along each row and column. So, for instance, when you look at this 2 by 2 place sign here, you discover that here it started with plus, then along the row minus, then come down plus, then go here minus. If you start from here and go here, after plus, it is minus. If you go here plus. So it should be well arranged and all that. So if I look at a 3 by 3, of course I'm going to be having plus. If I'm going along the row now, plus, minus, plus. And it was a 4 by 4, so I'm having plus, minus along the row. And if I come along the column, it's either with plus, minus, plus. Okay, and if you look at this minus, if I take from this minus now and go toward this side, after minus I will have plus, then I'll have minus. So it is very easy. I can even write a 5 by 5 place sign just very fast without wasting time, because it's an easy stuff to do. For instance, I want to write a 5 by 5 place sign. I'll just start with plus, then I'll alternate minus, plus, minus what? Plus. 1, 2, 3, 4, 5. That's it. Then just come down here now, minus, since that with plus here, minus, plus, minus, and plus. You have completed this rule and this column. So what you now do is just fill up here, fill up here, fill up here, fill up here. Here is minus, here should be plus. Here, minus, plus, minus. Here is plus, here should be minus, plus, minus, plus. Here started with minus, then here should be plus, minus, plus, minus. Here is plus, here should be minus, plus, minus, plus. And so that when you check the plus sign, you will discover that it is actually neutral all round. Okay? So that is what we mean by a neutral square. Okay, so please note the place sign of every matrix. All right, so I think I can clean this. Anybody see writing? All right, so nobody is writing, so that's it. I can wipe it off. All right, so we want to talk about determinants of minor as our next topic. Determinant of minor. Okay. Now, why are we taking this? We are taking this gradually so that you understand, because this will lead us to a 3 by 3 determinants. Okay, because when you start forming 3 by 3 and 4 by 4, which is beyond the scope of high school, okay, you will need to break down to 2 by 2 or to 3 by 3, then from 3 by 3 to 2 by 2. All right, okay. Somebody is asking for a explanation of um, the place sign of a matrix. We say that the place sign of a matrix should be viewed as a neutral square. Okay? When we talk about a neutral square, we're talking about a square that has the equal numbers of positive and negative. Just like an atom that have equal numbers of proton and electron. But more to that, it alternates with positive and negative, starting from the uppermost left hand corner and moving along the rows and column. You will now have the place sign of every matrix, because they will give you, if they give you a matrix like this, for instance 3, if they give you a matrix, for instance, let's say 3, 4, minus 2, 0, 1, 4 and 5, 6 and 3 all over 5. Okay, each of these matrices have their place sign. Okay, for this 3 now, the place sign is positive. Okay, for this 0, the place sign is negative, which is this one, because that place matches with 0, and for this 5, its place sign is positive. Alright, so that was meant by the place sign of a matrix. So to every member of a matrix, there is an associated place sign for that particular matrix. When dealing with square matrices, okay, it's applicable to square matrices and not to other type of matrix, because this is actually used in calculating determinants. Alright, so you just start from the bottom. For this a 2 by 2 square matrix, of course, this is positive, by the row is negative, and if you come down positive, if you move here, you have negative. If you start for a 3 by 3, you're going to have positive at the uppermost left hand corner. Then if you move along the row, negative, positive. If you come down to the column, negative, positive. And of course, you balance up. Okay? For this 3 by 3 now, if I have positive, start with positive, then I alternate negative and positive. And I now complete for the column. This is positive, alternate to negative and positive. What is remaining for you to fill up this now? You should be able to, this is just a little common sense. You know how to just alternate this. This side now starts with negative. Here should be positive, and here should be negative. So I have alternated this part. This side now, this particular point started with positive, then here should be negative, and here should be positive. I've completed the place sign for a 3 by 3 matrix. Alright, so the same thing is also applicable if I want to write 5 by 5 place sign. I want to know what it is. Nobody's asking you to write it. It's just for you to know it. When you look at a matrix, you need to know the place sign of that particular matrix without doing this stuff here. This is just an explanation. Nobody's going to ask you to write a 5 by 5 place sign matrix for me. No. What they will do to you is they will give you a matrix 4 by 4, 3 by 2 and all that, and you should be able to look at an element, for instance 2, 1, 0, 5, this minus 1, 3, 4 all over 3, minus 8, 9. I should be able to look at this 5 now and just know that this 5, the place sign is going to give me what? It's going to give me positive. Why is it positive? Because if I take here as positive, where our place sign always starts, if I take that point as my positive, if I take this point as my positive, that is for 3, then definitely here is going to give me negative. That will be place sign of 0. And if I come down to where 5 is negative, I need to alternate to positive. That means the place sign for 5 is positive. So nobody is going to ask you to draw place sign, but you need to know the place sign. That is why I'm explaining place sign first. Okay? Nobody asks you to do this, but you need to know the place sign. When you see a matrix, as we are seeing here, when you see a matrix, you should be able to tell the place sign of each element of the matrix. What is the place sign of this element now? 3. Of course, if you want to just do, you can just start from here. This is positive, negative, positive. Okay, here is going to give you negative because it must alternate along the rows and column. So here is also going to give you negative. Alright, so that's what we're talking about. for that. Daniel, I hope that is well explained. Okay, so now going to determinant of minor, which we are going to use to end this section. What is determinant of minor? Determinant of minor, I have a chart. Okay, that's correct, perfect. So she said she understood. Okay, so determinant of minor, every element has a determinant of minor. We won't talk about every element, we're talking about every square matrix, okay, in square matrices, okay. This is applicable to square matrices now, but we're talking about determinants now, which is applicable to square matrices. So every element has its determinant of minor. This is determinant left after crossing out or neglecting the row and column. You don't cross out actually, but you cross out virtually, just with your eyes. Okay, I have done something below here. You can see something below here where I did a cross out. But that is, so you don't do this with your biro. Well, of course, if using your biro or your pencil to do that to make it easier for you, fine, go ahead and do that. Okay, so you actual word supposed to be neglecting. So this determinant left after neglecting the row and column of that element. For instance, I want to find the minor of the determinant of minor of 1. This is element 1. This is element 1. I want to find its determinant of minor. So its determinant of minor is when I neglect this row, when I neglect the row of 1, the row of 1 is this is the row of 1, and its column, the column of 1 is this. When I neglect those two, what is now left is what? We'll now see that what will be left is this element. That's what is left. 0, -6, 8, and 9. That will now become the determinant of minor for element 1, or for member 1. Okay? Similarly, if I also want to find the determinant of minor for, let's take 1 at the center, let me say for 0. I want to find determinant of minor for 0. What am I going to do? Just neglect the row of 0 and the column of 0. Now, what is the row of 0? The row of 0 is, this is the row of 0, neglect it, and this is the column of 0, you neglect it also. Whatever remains will now form the determinant of minor. So we cannot say that the determinant of minor for element 0 is equals to what? It's a determinant also. So 1 is left, 3 is left, so you're going to have 1, 3, then 7 and 9. Alright, so that is how determinant of minor is being formed. Every element, so this is determinant left after neglecting the row and column of that element. Alright, so we're going to stop here for this section, and of course we're going to continue in the next episode of this class, and I do hope you enjoyed this section. Akimbode, how are you?